Yes. As we know, Python is a scripting language. It is an interpreter also. Unlike C or C++, the code of the Python gets interpreted. As soon as the Python, interpreter encounters a statement, it executes immediately. Okay. Like any other language, in Python also we have data types. So the data types are, first of all, text type we say, it is string we call it as. In Python, there is no character type of data. Okay, so a string which has only one character is treated as a character type of data. In other languages, we have character type of data, but in the Python, we don't have character type of data. A string which contains only one character, we can treat as a character kind of data. And you can iterate over the string like an array. So by using index operator, you can be iterating over the given string. For example, I have something like this. I have a string called Python. Suppose I want to individually retrieve characters. In such cases, suppose here I write s equal to Python. So this is what it's a text type of variable, and we call it a string variable. In this I have stored Python. In order to access the individual characters from that, I need to use like this index of operator. So S0, then S1, then S2 can be giving us individual characters from that. So S0 gives here P, this equal to here P, and when we go with the S1, this is Y, and when it is 2, this is actually T. Like this is going to be retrieving individual characters. So in such cases, you can think Python string as an array of one dimension. In other languages, we have arrays, but in the Python, we don't have. But only in the case of strings, we can think it as an array. One character we can retrieve using index. So here 0 index, 1 index, 2 index, and the last character is going to be length -1. So in the Python total, we have six letters or 6 characters. The very last character you can retrieve using S of 5. So S index of 5 can give you n because it has 6 characters. The very first character we start with 0, and the last character is going to be length -1. 6 minus 1 is 5. So like that we access in the Python string. So it doesn't have any character type of data, but using index of operator, you can be retrieving individual characters from the given Python string. Now we have numeric types in this. Just I'm reviving things. So we have numeric types. As far as numeric types are concerned, we have in this int, then we have float, then we have actually complex. Okay, so int is absolute number, float is approximate number, and complex is when you have something under root -1, you can treat it as complex number. If you take under root 1, it is going to be plus or minus 1. When it's under root 4, it's going to be plus or minus 2. But when you take the under root -1, you cannot get anything. So such numbers can be called as complex numbers. In mathematics also, I think you studied about the complex numbers. So
yes,
under root -1 is nothing but a complex number. Like that, it's going to be dealing. Then we have sequence types. Okay, we have another type of data called as sequence types, in which we have a list, then we have a tuple, then we have actually range. So these are the sequence types. That means sequentially they get saved data. They are going to store data. So list is nothing but it is a immutable kind of thing. That means data in the list you can change. Even you can increase the list size and you can decrease in the sense you can reduce it, okay, by removing an element, and by adding an element you can enlarge the list. So you can append and you can remove elements from the given list. Whereas tuple is not like that. Tuple is read only. Once you create, you cannot modify. It's only for read only purpose. Just to read only we use the tuple. So range is basically a range of numbers like 1 to 10, 1 to 50, 1 to 60. So when you want to take in such cases, we can use the range. So this is called as here sequence types. A list is a sequence type, tuple is a sequence type, and range is a sequence type. So numeric types are int, float, complex, and sequence types are list, tuple, range. So the list can contain any kind of data. It's aggregate, we can say heterogeneous. Tuple also in the same way, but range can give you range of numbers, range of integers it can give us. Now next thing is mapping type we have. So mapping type is nothing but you have a key and you have a value. So that is nothing but here a dictionary. We have a dictionary type of data in which you save data using key and value. For every key, there is going to be a value and key should not be duplicated. That is called as mapping type of data. It is dictionary. Okay, so we use dictionary for that purpose. Similarly, we have set types. Set types are nothing but we have one set, then other one is actually frozen set. Okay, we have two different ways of representing data as set. One is set, other one is frozen set. I'll explain more about the frozen set as we advance. Then other thing is bool type or say boolean. So boolean types are nothing but true or false. Boolean types are true or false. Either we have a true value or false value. And we need to remember one point, Python is case sensitive. It does differentiate between uppercase and lowercase. Like C, C++, Java, C Sharp, JavaScript, it is going to be differentiating between uppercase and lowercase. So C is what, the Python is what, a case sensitive language. It does differentiate between uppercase and lowercase. Okay, then similarly, we have here binary type of data also. So binary type of data is like we have byte. Similarly, we have a byte array. Then other thing is memory view. So these are the types we have as far as binary data is concerned. What is binary data? For example, we have a number like a equal to we write 100 and a b equal to we write something like 100. So this you can call as binary data. Just in one byte you can save 100. But in the B, when you put 100, this requires 3 bytes because everything is going to be like a ASCII character. 1 is an ASCII character, 0 is an ASCII character, again 0 is an ASCII character. So this requires 3 bytes and this is going to be using just 1 byte. So internally, it's getting saved in the binary format. So binary format means the given 100 is converted to binary number, then that will be getting saved. So in the form of bits, that will be getting saved. Even in the case of B also same thing, but for every character we represent here, 1 byte is required. Here for 1 we require 1 byte and for 0 another byte, another 0 it requires another byte. So internally this requires 3 bytes, whereas A requires just only 1 byte. Because this is a string and this is what integer, internally it's nothing but binary data. And apart from this, sometimes you need to deal with the image files. Okay, how do you deal with image files? Sometimes you need to retrieve image data from the server to client. So in such cases, like byte array we can use. So bytes of data just we retrieve. Okay, similarly it may be sound file, it may be image file, or it may be some movie file. So in such cases, we are going to treat it as byte or byte array. In that manner we can be using. And sometimes you need to maintain memory files in memory. In such cases we use the memory view. So these are the types available with the Python language: numeric types, sequence types, mapping types, set types, then boolean types, and other thing is binary type. And as we know, Python is a case sensitive language. And in the Python, we end a statement using enter key. When you press at the end, whenever you press at the end of the statement enter key, it goes into next line. That will be treated as actually a next statement. Okay. And another thing is Python, for blocks, Python uses indentation. Whenever you take any other language, C, C++, Java, there also we use indentation. That we use only for decoration purpose and for just for readability purpose we use indentation. But in the Python, we use indentation for scoping purpose. Scope means a block. You can create a block using actually indentation. Block is nothing but a compound statement. In the C language, you might have come across statements like single statement or multiple statements. So, I mean, you can put more than one statement together using curly brackets. That is called as actually, that will be treated as actually like single statement only. So for such purposes, we use curly brackets. But in the Python, we use the indentation for blocking purpose. Okay, so whenever you write a function or whenever you write a loop or whenever we write some try-catch block at the time, we use it. I'll open yesterday's one and show you how I am using that for blocking purpose in the try-catch block. So Visual Studio Code I open. From here, I show you. Okay, so whenever you look at this, we have a try colon, then here you have certain space. This is nothing but indentation. Between line number 1 and line number 2, when you see right side, it's getting moved. And whatever you have in the try block, this is nothing but it's a scope. The first num is available only within the try. If you try to use the first num outside the scope of the try, you cannot use it. So using indentation, we are making a block here. Suppose you use some C code also, I try to write here. Something like this, I write a for loop, then in this for int x equal to 0, then x less than 10, followed by x plus plus I write. Then suppose you need to execute more than one statement. In such cases, you put the curly brackets. Inside the curly brackets, you write code. This is what exactly blocking. So whatever variable you declare inside the for loop is going to be available only within the for loop. Outside the scope of for loop, it will not be available. So here we use curly brackets for scoping purpose. So in the Python, we use indentation for scoping purpose. So using indentation, you are going to make scope. So the scope for try is from this line to this line. Now except is not part of try. Except is actually extended block of the try. When the try part is getting any error, it comes into except part and that part of code will be executed. Okay, so Python is what here? It depends, it uses indentation for scoping purpose. This you can think as scope. Try is one scope and except is here another scope. So like this, we write here. The next thing is casting. We talk about actually casting. So casting is nothing but it is actually converting one type into another type. Whenever you try to convert from one type to another type, that we call as casting. Okay, in the C also we use casting. For example, you have int some a equal to 10. Similarly, I have here b equal to like float b I put here. Float b I put like this, float b equal to 23.4. Suppose now I want to convert b into integer. So in such case, what I do, a equal to, I put like this, then I put before this int, then I write here b. So what happens in such cases? Forcefully it is converted. The value 23.4 is forcefully converted into a. This is called as here typecasting. And in this process, what happens? It's going to truncate 0.4. It's going to lose data because the fractional part cannot be saved in the integer. Only it can hold integers. It cannot hold the fractional part. So therefore, it's going to truncate it. In such cases, we are going to lose the data. Basically, there are going to be two concepts in this. One is widening, other one is narrowing. So here, what exactly this is narrowing? I mean, we are taking bigger type and we are converting it to smaller type. So with that, what happens? It's going to be getting narrowed down. Some of the data you may lose. Whereas if you write b equal to a, here there is no problem because this is nothing but widening concept. A you are converting into float type of data. There is no problem with that. But whenever you try to write b equal to 23.4, like when you write a equal to b, this is a problem because you need to lose some of the data, and this concept is called as narrowing down. So whenever you go with the casting, what happens? You are going to narrow down the size of the data. So in that process, you are going to be losing some type of data, some data in that. Now in this example, in the line number 9, when you write 23.4, you are going to lose 0.4 from that. You have only 23 in that. So casting is going to be sometimes a problem. That means you may lose some data if you go with the casting. Okay. So casting is what basically, but in the Python, using actually constructor function, we are going to be converting data from one type to another type. So basically we have these casting mechanisms, int, then float, other one is str. So we have three different things. With the help of this, we can convert data from one type to another type. For example, I have something like this here. I write here num equal to, I put int, then here I write 100. 100 is what? It's a string. 100 is nothing but a string. So that string I'm converting into number here. It's nothing but integer type of data. In the line number 2 also same thing is happening. Whatever you enter from keyboard, it is going to be in the string format. And that we have to convert into number. So therefore we are using here typecasting mechanism. So casting in the Python we use as a constructor function. Int is nothing but a name of the constructor here, followed by in the brackets we specify what value you want to convert into integer. Now similarly we have here f1 is equal to, we write float, then here in this you can put 34.56. So this can convert the 34.56 into a floating point number. So this can convert into approximate number here in this. It is giving you floating point number, but the first one is giving you integer. Similarly, when you have something like this, S1 I write. S1 equal to, here I write str, then followed by here I may put some number. I put 123.45. What happens in such cases? This will be converted to a string. 123.45 is nothing but a number. That number we are converting into string. So like this we use here three constructors: int constructor, float constructor, str constructor. So the first one is converting the given string into number. The second one is converting the given string into a floating point number. And third one is converting 123.45 into a string. So here like this we use the constructor functions, casting functions. So these can be called as your casting function, and like a constructor function we use here. Constructor means it takes same name as the type of data, then it uses the parameter. Okay, normally the C++, in Java you come across constructors. Probably when you were doing BTech at that time you came across, I think, such things. In the C++ or in Java, you might have heard the word constructor. So it's same thing here. So it takes same name as the data type name, then followed by whatever value you are passing here. So that is called as parameter. It is nothing but like a constructor function we are using here. It is converting 100 into a number, and this is converting the string into number, and the last one, a number, is converted to string. So let us try to print these things. Print. Here what I say, I want to add the two numbers. First thing is num plus f1. Num plus f1. So the result, what we expect in this case, this has to be 134.56. Next thing, print. I write here s1, then write the length is, I put like this, and here I put another like comma, then I put here length of s1. It can give the length of the s1. That means how many characters are in this. This can print for us. Now let us run this. Okay, so this is giving some problem. Let us go to command prompt and from there try to see that. But this one where I have saved, okay, save as, I can see with this. Okay, Python CSV, the G drive, that is.
I think you did not put the extension py file.
It is already existing file, as first1.py file I have, and I change here this to like cd, and in this it is Python CSV. I'm writing code in the same file, so I put here Python followed by, it is sfirst.py, sfirst1.py. So first number I enter 23, then I enter 56. Now what it says here, it is printing the result as 79 first. From where we get 79? 23 plus 56 is nothing but 79. Then after that what we do, we are adding f1 and s1, num and f1. So that is giving us 134.56, and at last what it's saying here, 130.45. So in this we have total 6 characters. 123.45. So here we convert the given string into number, and in the last, in line number 10, we are converting the given number into string. Often we require these conversions, string to number, number to string we require. So in such cases, we can use these things. Okay, so these are what here we converted a string to number and number to string. So here with the help of the constructor functions, we are casting the type. We can cast the type like this. Okay. So similarly, we have Boolean types like true we have and false also we have. And apart from that, we talk about actually now operators. There are different types of operators we have. As per the given thing, as per the given document, we have many types in that, like addition,
one,
then
Sridhar,
subtraction. Yes,
1 second. Can you give me the examples of programming the list, tuples, and range?
I'll give that. But first, let us finish this. That takes some time actually. We'll understand
Oh,
later on that one. So
and can
once,
you go a little bit slow?
yes, no, we go slow, but I'll give those examples later on. First, let us finish
Oh,
this basic things,
okay.
because in
Okay.
combination we need to use them. So we
Oh,
have
these are
here,
all operator. Okay,
yes,
okay. I thought
operators.
you were.
No, no.
Okay, okay, okay.
So this is
Okay.
addition, then subtraction, multiplication. Then we have here
Okay.
division, then followed by
Okay.
modulus operator you have. Then
Oh,
after
okay.
that,
Yeah.
we have
Okay.
here like uh, we have actually here we are going to have something like this here, two slashes we have. Okay,
Okay.
so and other thing is like two multiplication symbols also we use.
Okay.
Okay, so
And what?
this is for
Sorry.
addition, this is for
Okay.
subtraction, this is for multiplication, this is for
Okay.
division, and this is for modulus operator. We use it for
Okay.
modulus operator. That means for finding out remainder. And this is for actually we can use it for floor. Floor means, for example, you have 7. When you divide 7 with 2, what result you get? Normally you get 3.5. When we use
Yes.
this, it's going to give you 3 only. This gives you 3.
Okay.
And whenever you go
Okay.
with this star star, this is going to give you exponentiation. Suppose 3 star star, if you put 2, it's going to give you 9. So if you put 3 star star 3, it gives you 27. So like that we can
Okay.
use. I'll show those examples now. Here in
Okay.
this, I have one, I put num1, this is equal to, I put something like 20, then num2, I put 7. Now let me print it. Print here num1 plus num2. This is for addition purpose. Similarly, print num1 minus num2. This is for subtraction purpose. Print then num1 multiplied with num2. This is for product purpose. Okay. Now similarly, print we take here, then write here num1 divided by num2 we write.
Okay.
So this gives you here when you divide first number with second number. The next thing is here print, then here it is num1, then this can be a very big number if you take 2 here. So what I put, I can take here num2. Okay, then I put here exponent symbol, that is going to be star star. Then here I put something like 3. If I go with the 20 and 7, that gives a very big number. So this is we can verify easily with this. Then print, the other thing is here, when you go with the 20 and when you take here num1 and try to divide with, sorry, so here num1 slash slash num2 I put like this. So this gives addition. I can put like addition here. Okay, but to give a space little. Then here write subtraction. Okay, here it is product. I put it as product. Okay, product I put. The next thing here is division. We put like here division. Then this is exponent. This is what exponentiation. And the last one is here floor division. We put like this. So when we run, what result we expect in this? The result has to be in this. I put here hash. What result we expect? 27 we expect. Similarly, the result for this is here we get 13. And when you go with this is going to be here 140 you have to get. And when you go with this here, what exactly you have to get? When you divide 20 with 7, 7 2s are 14, 7 8s are 56. Okay, so this is 8, something like this you have to get in this case. And whenever you go with this here, you are going to raise num2 how many times? 3 times. 7 7s 49, 49 7s is how much? 343 you have to get in this case here. It has to be 343. And here when you divide the num1 with num2, this has to be 2 because 7 2s are 14 you get. Okay, so this has to be 2. The result we have to get something like that. Save this and go to prompt here. Again we do this. So what it says here, addition is 27, subtraction 13, product is 140, and division is what? 2.85, something like that we are getting. I said it as only just 2.8. Okay,
Yeah.
I could not calculate further, so I have put that much. And you can see here up to 15 digits you have precision. Up to 15 digits we have the precision in this case. After that there is no guarantee. Then in the case of exponentiation, it is 343. 7 7 is 49, and 49 when you multiply again with 7 you get 343. And in the case of floor division, this is actually 2. So in this way here it's printing. Okay, so operators are working in that manner for us.
Okay.
Now similarly, here what we are doing, we are assigning some values. For assigning we use equal symbol, but sometimes we need to go with the shortcut operators. So shortcut operators can be like this. For example, num2 here, right, plus equal to, you can put it as 10. So what it means exactly? It means here num2 equal to num2 plus 10. Like this we have to think in this case. It is shortcut. Num2 plus equal to what we have written? 10. So this is called as here assignment, but we are using a shortcut notation for that. Instead of writing num2 equal to num2 plus 10, you can write like this. Num2 plus equal to 10 we can write. This is called as here a shortcut notation for the assignment.
Oh, can you please repeat that one?
See, num2 plus equal to 10 we have written. So this is exactly what num2 equal to num2 plus 10. Instead of writing like that, you can write in this way. So you use operand, okay, then you use actually here the required operator, then you use the assignment operator at the end with whatever you are trying to perform arithmetic operation. So the other operand also you have to use. First operand is num2. So it's nothing but num2 equal to num2 plus 10. So instead of that, what we do here, num2 plus equal to 10 we write. Same thing with the subtraction, multiplication, division, with those things also you can use in the same way. You can write like this, num2 minus equal to, exactly you can write here 10. Similarly, num2 equal to, you can write it as num2, say star equal to, you can write 10. Sorry, this is not and, star you can put, equal to 10 you can write. So here in this case, it's going to be multiplying. There's nothing but num2 equal to num2 multiplied with 10. That way, we can use shortcut operators. So plus equal to, minus equal to, star equal to, in that way, you can write. So these are called as here shortcut operators, and these are also called as here assignment operators. The basic assignment operator is what here? Equal symbol. So using equal symbol, we can assign.
Okay.
Okay, so this is what, these are all arithmetic operators we have seen. Now let us come to some comparison operators. You can be comparing. So comparison operators are like this, equal symbol. 2 times when you use equal symbol, this is called as comparison for equality. Comparison for equality it is. Okay. Similarly, we use here not equal to. So this is going to compare for inequality. This is called as here inequality operator. So we can call this as, first one is equality operator. The second one is here what exactly? Inequality operator we say. Similarly, we can use like this, greater than, less than, we write greater than or equal to, less than or equal to. So these also we can use. These are also nothing but inequality operators. Greater than is inequality, less than is inequality, but greater than or equal to you cannot say as inequality, because in this you have both the things. Greater than you have, equal you have. So this second one also less than and equal. So these are also called as relational operators. Greater than,
Okay.
less than, greater than or equal to, and less than or equal to is also called as relational operators. Even you write here A equal to B, this also you can think as a relational operators, because you are trying to compare both sides of the expression. A equal to B, when you say you are comparing operand A with operand B, so in that process that can give a true value or false value. If A and B are same, in that case what you get? You get actually true value, otherwise you get false value. Okay, so like this, even this is also can be, this also can be called as here a relational operator, or we say here comparison operators, either comparison or relational operators, you can say them. Now let me show you this as example. Now I put here some other number, x equal to, I put 10, then I write y equal to 20, I put, and z equal to, again I put 10. Now I want to compare this. Print, what I do here, x equal to y. I put like this here. What I do here is x and y same. I put a string like this, then I compare here the operator. So this has to give me a true value or false value depending on the value is available there. Then similarly print, I put here is x and z are same. I just put same. Then here I can write x equal to z. I put like this. So this is going to compare whether x and z are equal or not. Similarly, first one, whether x and y are same or not, they can compare. So this is what exactly, these can be called as here, I mean equality operators. In the same way, I can try with unequal operators. I can take this here and I can compare with the inequality operator like this. What I say here is x and y are, is x and y not same? I put here, but in this case I compare with the unequal symbol, inequality operator. Okay, so here also I put like this, not same. So this has to be here, again compare with this. Now here what should be the result when I take this? This has to print false for us, because the values in the x is 10, y is 20. So x and y cannot be equal.
Yes.
Therefore, it is false here. But when it is here in this, what is exactly? It is going to be true. It can return a true value here for us. And when you go with this, what this has to return? This has to return as a true value. And this has to return a false value. Because if you look at this, here see x equal to y, this is false, that's why it returns false. X equal to z, so
False.
x and z are same, this returns true value because both of them have 10 value.
True.
Now here when it comes,
Yes.
x not equal to y, because x is not equal to y,
Yeah, it's
therefore
true.
it's true. Okay, but here since x and z are
Yes.
same, this prints false because we are using here operator inequality. So like this is printing.
Okay.
Similarly, we go this way. Print here, right, is x greater than, what I put here, y. So here I come and put x greater than y. So x is 20, x is 10, y is 20. Therefore, it says here false. We expect result as here false. Okay. X is greater than Y because Y is 20 and A is 10. So this is going to be giving you a false value. Now similarly, I go with print. Here we write, okay, what I write here is X greater than Z, I put. So this also has to give us a false value, X greater than Z, because they are same. Since they are same,
Okay.
even this also has to print for us false.
False.
Okay, because X and Z are same, so X cannot be greater
Same.
than 0. So in the same way,
Greater
I
than.
can
Yeah.
use this. I'll try to compare with the less than. Okay, I can compare with less than here. I can go this way here. I can write less than Y. So now it should print actually a true value for us.
True. Yes.
It should print a true. But here again, this is going to be printing false for us. So like this, we can use. The first one is what here? Equality operator. Since X and Y are not same,
Yes.
this has to return false value.
Same.
But in the next case, X and Z are same, that returns a true value.
Same.
Now we come to
True. Yeah.
again X not equal to Y. So that returns true because X is not equal to Y. Therefore, the condition is what here
Right.
getting satisfied, we
Yeah.
get a true value.
Yes.
So similarly with the Z, also with
Yes.
the X greater than Y, Z greater than Y, X less than Y, and Z X
Yeah.
less greater
Yes.
than C.
Yeah. You
So
can
like
change
this we put here. Here I should change it. Okay, I have changed it. Now
Yeah.
we need to run this.
No, no, you can change the X great instead of greater than, you need to, you have to write less than, right? The last one.
Correct only. Because we are comparing for this time for less than.
Oh,
Earlier we
oh no,
compared with greater than symbol.
these ones.
Yes, this one. Now earlier we compared with the greater than symbol.
Okay.
Correct? Now we are trying with the less than symbol.
Okay. Yeah.
Yes, I just said.
No, no, no.
we need to
I'm
change
right.
this.
Here. Yeah. Yeah.
Yes.
Less than. Yeah.
This is just for our understanding purpose. Okay.
Yes. Yeah.
So save this and let us try to run again this one. Now what it says here, X and Y same, false it is. So we are printing it as false only. Because X value 10, Y value 10, 20, and Z equal to 10. Then say X and Z same, true that is. X and Y not same, true.
Okay.
X and Z not same, false it is. X greater than Y is false. X greater than Z is false. X less than Y is true. And X less than Z also false. Because X and Z are equal. So like this, you can actually evaluate. You never use like this. You are going to use actually with if condition or with the while loop all these. But just I'm explaining how these are going to be working, how they are going to return true or false values.
Okay.
Okay. So similarly, what we have operators like identity operators we have.
Okay.
We have identity operators. So in the case of identity operators, we write like this. It is something like is we have and is not. Okay, we have like this is and is not. Now let us try to use same thing here in this. We come to here in this. So is nothing but we are trying to compare first operand with the second operand. We are trying to compare first operand with the second operand. So when we say x is y, x and y are the same, x is not y, is x and y are different, we are going to compare. So therefore, let us see that example also here. Is x is y, I put, sorry, not there. Okay, how many times here I put is x is y. Similarly, is x is not y. Okay, not y I put here. Okay, so x is y, this has to return as a false value, and this has to give us a true value. Let us see and run this. And here operator, I have to change it. I need to write it as x is y. Similarly, here I should write x is not y. I should write here. I'm trying to compare with the y. So now let us run this. So x is y false, x is not y true, it is same, because they are not same, they are different.
Yes.
This time we try with the z. What happens? Let us see in this.
Okay.
We take z here and we try with that. So x is z true, x is not z false it is. So these are identity operators we say. Whether they are identical or not, they are saying here, we can call them as identity operators. So x is z is true,
Okay.
because, but x is not z is false. So like this we can use the identity operators sometimes.
Okay.
Practically when you write code at the time, all these will be useful. Depending on the context, we have to use those things. All operators we may not
Okay.
use. In some particular application, we may use few operators. Whatever you learn in Python, in all applications, we may not implement all the things. Depending on the requirement, we have to use them. The next thing is what
Okay.
membership operators we have. Okay, so we call this as membership operators. Here it's nothing but you take one element, whether the element is a part of some other element or not, we write. So it is in and not in we use. We use in, something like x in y we write. Similarly, we write not in, it's going to be x not in y. Like this we use. So whether x is a part of y or not, we can find out. Now let me create something like this here, with that you can understand.
Okay.
I create here a variable called s2 I create. So s2 is welcome I put here. I write a string welcome here.
Mm-hmm.
Okay, so welcome to Python I put. So s2 equal to welcome to Python I put, and here what I do, s3 equal to I put like right here 2 in this. Okay. Similarly, s4 equal to I write it as then. So we try to now find out whether 2 is in the s2 or not. Similarly, then is in the s2 or not, we need to find out. Whether the 2 string is available with the welcome to Python or not, we need to find out. Similarly,
Okay.
then is available in the welcome to Python or not, we find out. So therefore here we print, here see. Yes, we write like this. S2 is in, we write, sorry, S3 is in S2. We put like this. Okay, so here we go with this, then we type here S3 in S2. We write like this. Similarly, we take this one and not in also we use here. Not in. Okay, same thing I take here, is not in. So same I can use here and write here this S3, S4 is in S2 and S4 is not in S2. Like this we write. So what results we expect in this? When we say S3 is in S2, this has to return a true value.
True.
Okay.
Yes.
But S3 is not in S2, this has to return actually false value.
False
Yeah,
value.
when it comes to S4, S4 is in S2. When we say it is in this case here,
False.
it has to give actually a here it is false value, but this should give true value. Like this, you have to get the values.
Oh.
What it says here, S3 is in S2 is true. Reason, 2 is part of actually welcome to Python. If you look at the string welcome to Python, 2 is in that.
Yes.
Okay.
Yes.
Similarly, when we say here S3 is not in S2 is false because it's part of the S3. So therefore that is returning false. In the same way, when you take S4, S4 is then is not part of actually the S2. So therefore, what it says here,
True. Why?
just
Oh, sir, 1 second is.
I haven't changed this one.
Oh.
Same S3 I copied. That's the problem. I should change that. Then you get exactly. See, for us, prompt is looking like this. These can realize sometimes bugs. Program works fine, but result what you expect you never get.
Yeah.
So such things are called as bugs. There should not be any bugs in the code. In a hurry, we are writing code. So we need to write very carefully. Then you have less bugs. Still, you cannot avoid totally bugs, but you can avoid to a great extent if our mind is present in that case. My mind was not present when I was writing. So in a hurry, I was copied and pasted there. Okay, so here S3, S4 is in S2 false, S4 is not in S2 is true. So like this, these are nothing but membership operators. Is in, is not in, we use. So even we can use them in the like list tuple, there also we can use it. I show that example also here. I put something like here LST equal to here I put like 10, 20, then 30 I put. Then what I do here, print. Okay, I can print here is okay. I put here like 2, then followed by I put ls 2 is in ls. I put here another string is, then followed by put comma here, then I write so 2 in ls. I write like this. So this should give here a false value for us. This should give us a false value. Just I run this. What it says here, 2 is in 10, 20, 30 is false because 2 is not a member of in this particular list. We have only 3 elements 10, 20 and 30. Therefore, it gives here false value. Okay, suppose I change this one. I put it 20. Then in such cases, you can get it as true, it says. Now what it says, 20 is in 10, 20, 30 is true because 20 is part of actually the given list. Okay, so these are basically membership operators, is not are two membership operators. And before that we had actually identity operators. So in the case of identity operators, it was is not. Okay, it was is not, but in this case what in, not in. As far as membership operators are concerned, it is in and not in. So with that you can find out. Okay, so mostly with the collections we can use this.
Okay.
Now next thing is we have bitwise operators. Okay, we have bitwise operators. They work on bits. So first thing is what? And. This is called as bitwise and operator. We say this as bitwise and this is here bitwise OR operator. When we use pipe symbol, it is bitwise OR operator.
Oh, pipes.
Similarly,
Okay.
it's pipe symbol that is. Then we go with the caret symbol. This is called XOR, bitwise exclusive OR it is. Similarly, we have here tilde. Tilde is for inversion. Okay, this is called as not inverts bits.
Okay, what is the last one?
It's called tilde character just below the escape key on the
Tilde.
keyboard
Oh,
you find.
yeah.
Okay, so not this inverts bits. It's basically not we say bitwise not it is. This is what bitwise XOR
Okay.
bitwise not it is. Okay, and this is what bitwise exclusive OR operator. Okay, and this is bitwise not inverts bits. Similarly, we have here
Okay.
like shifting operators. It is called as right shift. Bits get shifted towards right side, and this is here left shift. So here it's going to be shifting bits towards left side. Now I explain you how bitwise AND operator works. For example, I have 10 and I have 15. Okay, I have two numbers 10 and 15. Whenever I perform here 10 and 15, what happens? See, I go with the 10 and 15. So it's going to work at the bit levels. Okay, so when they are working at the bit levels, when you convert the 10 into binary format into bits, what do you get exactly? It is, okay, first it's going to be in the units position 0, in the twos position 1. So 0, 1 we put, sorry, this is, we put 1, 0. In the units position 0, in the twos position 1, in the fours position 0, in the eights position 1 you have. Then in the 16th position 0, then in the 32 position 0, in the 64 position 0, in the 128 position 0. Like this we have. This is equal to 10. 10 is nothing but 1010 when you convert into binary format. How many bits in a byte we have? 8 bits, correct?
8 bits.
Okay.
Yes.
So when we convert into binary format, the place values change. First thing is units, then twos, then 4, then 8, then 16, 32, 64, 128. Okay. So 0 into 1, 0. But here in the twos place, how much you have? 1. 1 into 2, how much it is? 2. Okay. Here
2.
in the fours place, you have 0. 4, that's value is 0. But in the eights place, you have 1. So 8 plus 2, how much it is? 10. So decimal 10 equal to
Yeah.
0001010 in the which one, that is binary format. Okay. Same thing in the case of 15. So how 15? 5 extra we need to add to that. So add like this 0,
2. Yeah.
0, 0, 0.
See.
Then this is 1 we need to put. Then the fourth place 1 you need to put in the I mean twos place 1, but in the units place 1. This is nothing but 15. Correct? Yeah, units
Yes.
1, 2 is how much? 2, 2 plus 1, 3. Then 4's place 1. So 4 plus 3, how much? 7. The 8's place 1, 8. 8 plus 7, how much it is? 15. You get 15, that one.
15.
Okay.
Yes.
Now when we go with the bitwise AND operator, what happens here? They are going to be working on the bits. So on the in the first number, in the units position, what you have? You have 0. But in the second number, in the units position, how much it is? 1. Okay. So when both are ones and when both are zeros, then only that will be taken. So what happens here? In the leftmost position, this is going to be 0 only. In the leftmost position, 0 you have, because in the first number you have 0 in the units position. In the second also, in the second you have 1. So both of they are not same. Therefore, it can't take 1. It takes only 0. And meaning is what here? Both operands should be 1. Then only it can be 1. If any one of the operands is 0 or all are 0, it's going to be 0.
Okay.
Now next thing, here what you have in the twos place 1, in the second number also in the twos place 1, 1 and 1, 1 that is. Okay. Then after that, in the first number in the fourth place 0, but in the in the second number in the fourth place that is 1, but result is what here? 0 only. Similarly, in the eighth place, in the first number 1, in the second number also 1, 1 and 1 is going to be 1. So similarly here, In the 16th place, both are 0. Here also 0. In the 32th place, 0. In the 64th place, 0. In the 128th place, also 0. So therefore, result is what? When you perform 10 and 15, result is going to be 10 only again. We get same number. Understood this?
Yes.
Now let me show this, how this bitwise AND operator works. So I have here like N1, I take as 10, N2, I take as 15. Now print, I take like this, 10 bitwise AND 15. What is the result we get here? We need to go with the bitwise operator and write this N1 and I write here N2. This has to print for us 10 only value. So let us run that and see. What it says here, 10 bitwise and 15 is, how much it is? 10 you are getting. So what we did, it was correct in that. Okay. Now similarly, if you go with the bitwise OR operator. Now with OR operator, what happens? See, here we take this time bitwise OR operator. So we go with here OR operator. I use here pipe symbol. Then in this, I try to do both of them. So either it should be one either in the first number or the second number or in both. Okay. So this is what here, either in the first one or the second one, or they can be both. When either in the first number or in the second number it is 1 or both are 1, it is going to take 1 at the bit level.
It will take 1.
Yes.
Yes.
So here 1 it is. Sorry, not there. Here I put number. It is going to take 1. Next thing is what? Again it will take 1 only. Because
1 only. Yeah.
1. In the third one also take 1. So it's take 1. The rest are going to be zeros. So this time what you get 15 you have to get. Now when you go with this.
Yes.
Okay, so now it is put here, print. This is bitwise OR 15. So result must be 15 for us. Sorry, what I did, something mistake. So it says 15 this time. When we use bitwise AND operator, at bit level it's working. So when you go with the 10 bitwise or 15, it gives you 15 only. So you are getting the result as here 15. That means at bit level, the operations are getting done. Similarly, we have the XOR. So XOR means either the first one or the second one. We take like that. But both cannot be true in that case. Okay. So either the first one or the second one, it has to be 1. In that case, that will take as 1. Otherwise, it takes actually, 0. So as per XOR, when you go with the 10 followed by here caret symbol, then I put here 15. So what result we can expect from that? 1 and 0, 1 we get, that is okay. But in the next one, 1, 1, that is 0. Okay. Then in the third one again, 1 and 0, you get 1. But when you go with the fourth one, 1, 1, this is 0 again. So rest are going to be 0. Like this we have. Therefore, this gives you how much for us? 5 the value should be for us. Units place 1, 2's place 0, 4's place 1. 4 is how much? 5. So when you go with exclusive, XOR operator, we have to get it as 5 in that case.
Okay.
This is called as caret symbol when we use, it is called as exclusive OR operator. Okay, here we need to put the symbol caret. it says 5. You can see 10 bitwise, then caret symbol 15 is nothing but here 5. So it's giving you 5 in that case. Now next thing here is we need to invert. So inversion meaning is, suppose I have a 10. I have number 10 in the n1. n1 equal to 10 I have. Now I need to invert all the things. That means whatever bits, whatever in whatever position you have ones, they should become zeros, and in whatever position you have 0, they should become 1. So therefore, when we invert that, what we have to get? 0 0 0 1 0 1 0. So it has to be getting inverted. Therefore, we get it as 1 1 1 followed by 0 1
0
0
1
1.
0.
Like this it has to be. So what is the result with this? Units, then 4
2
5,
2 0.
5 plus 16, how much we get? 21. 21 plus 32 is how much? 21 plus 53. 53 plus 64. If you go with 53 plus 64, it's going to be 117. 117 plus 128. So 117 plus 128, you
Got
get
it.
actually that as 245. I think we need to get that. So let us see the calculation here. It has to give us 245 if I am correct in calculation. So let me see that here. But it takes only one number. It is going to use just one number. It doesn't require two operands. It requires only one operand, because you're going to invert, see, bitwise followed by, I put here, sorry, this inversion not, I'm going to do like this, and this will be here tilde followed by n1 I put. So that should give us how much? 245 we need to get in that case.
Okay.
So if our calculation is correct, so you get in that way. It's saying -1. Why it is -1? The reason is, if you look at integers, they support both positive and negative. Okay, they can support both positive and
Okay.
negative, and the very last bit is used for sign purpose. If you look at this here, you have bits like this. The last bit, for what purpose we use? We use it for signing purpose, for minus,
Okay.
for a positive number or for negative number. So otherwise, the rest you are going to get with that as -11. So ultimately, you are going to get that as -11 when you go with that. It's giving you just -11 only.
Okay.
So internally, it calculated like
Okay.
that. Unlike C language, in the C you have positive numbers and negative numbers. Unsigned you have, signed you have. But in the Python, there is nothing like unsigned and signed. Everything is going to be signed. That means they can take negative and positive numbers.
Okay.
So therefore, it's giving you here -1. Whenever you invert 10, you are getting it as actually -11. So this way bitwise can be working. Similarly, we have here shifting operators. So if you look at this, bits can be shifted. I have something like, this is called as uh, right shifting,
Left shift.
and this is called as left shifting. Left side can be shifted and right side can be shifted. Now suppose I have here 10. Okay, so I have 10 here. 10, I have a number n1 equal to 10. By 4 bits,
Okay.
when I shift towards right side, that should be 0, because it is going to move towards right side. So in that case, whatever in the, whatever in the left side you have, they are going to be coming into this location. Okay, so therefore in that process, what happens here, we have zeros. It will be becoming all zeros, and to the left of that, what happens? Zeros will be replaced simply. What happens here? You have 4 zeros here, and this is what 1010. Whenever you are shifting bits by 4, what happens? Whatever zeros you have here, they are going to move towards right side, and in the left side,
Okay.
the empty places are there. There you have the zeros. They get embedded zeros. So what happens now
Okay.
when you go with 4? It is going to be giving you 0 only. But when you shift by 3, it can give you 1. So let us see that.
Okay.
Okay, here in this right, this is right shift by 4. So here it is N1. We write like this. So like this we need to write. Similarly, if we want to shift by 3 bits, what we get, see in this. Right shift by 3 here. But here I haven't put anything. Sorry. N1, 4. Here also we require comma. Then we write here N1, 3 it is. But original values, whether they change, we need to see in that. Whether original value is getting changed, we need to check that.
Yeah. Okay. Comment.
Now, in the first case, what it says, right shift by 4 is giving 0, right shift by 3 is giving you just 1. Because 3 bits, they're getting shifted as per this code.
Okay.
So in the same way, we can try with the left shift also. So you try that left shift, you can try. Any questions, Swati?
No. Okay. When I doing maybe programming, when I practice, maybe I may get
Yes, at the time.
doubts. Yeah. So far I'm good.
Yes. So I share content like that every day. Go through that, please. So
Yes, sure.
if you go through the code,